Huh?
Yeah, it's recording. Can't you see the whiteboard? Are you seeing the whiteboard?
Yeah.
Well, I can't see the whiteboard. How come? I can't see what you're seeing.
Do you want me to restart it or whatever?
No, I can see it now. I can see it now. Okay, let's get started. So let's say you've got a triangle here. Hang on, let me think. 3, 4, and 5. Okay, Chelsea. A right angle triangle.
Yes.
You could have told me the dimensions of the biggest rectangle that I can fit inside this triangle. So, for example, you can make it this big. You could be looking at this purple triangle, or you can make it really thin, like this one here, green one, or somewhere in between. Let's say this red one. Hang on. So somewhere in between. Which triangle? Look, just glancing at it. Which triangle? Oh, sorry. Which rectangle do you think will give you the biggest area? Green, red, or purple? Just by looking at it.
Purple.
Purple.
No. Red.
Yeah, it seems like the red one, just by glancing at it, and we don't know for sure. We're just guessing that it could be the red one. So somewhere in between the two. Well, it won't be this one here, Chelsea. Hang on. It won't be this. It won't be this one here. It won't be this thin one here, or this one here. You see that? So it's somewhere in the two. You can see that the middle one is massive in comparison to the other two. So your job is to tell me the dimensions of the biggest rectangle or square that I can fit inside this triangle. And dimension, when I say dimensions, I mean like the length and maybe this length here. So how do we go about doing this?
So how do I do that?
Right, but do you understand the problem?
We're trying to find out the area of
the
biggest area that can fit into the triangle.
Yeah. So what we do is we're going to use decimals to simulate the problem. So we're going to draw some in decimals. This is the origin. We're going to draw a straight line like this. Okay. The intercept is 3, and the length here is 4. So what's the equation of this line? Because we've got to draw in decimals, and then later on we can add a slider where we can slide it back and forth, and then scan through the whole problem to find the biggest area. But the first step is to come up with the equation of this line. What is it?
Of the straight line?
Yeah.
Y equals mx plus c.
Okay, y equals mx plus c. You need to know the gradient and you need to know the intercept. What's the gradient? Because I want you to draw a straight line in decimals where it goes through 3 and it goes through 4.
Hold on. 1.
1 what? What's 1?
Wait, the thing is 1. The gradient is 1.
No, it's not. 1 y. If you have 1, it will give you a graph y equals
1 over 0.
No. If you have a graph y equals 1, it will look like a straight line looking like this because it's going uphill because of gradient positive 1. First, our gradient is going downhill, so it should have a negative. Negative what?
1 over 0.
No. I think your method here is not correct. This method here is not correct. So the gradient is really the up and down divided by the across. Right, Charles?
Okay.
So hang on. Let me clear this up, Chelsea. Hang on. I'm going to grid. Bear with me. If I were to give you a line looking like this, how would you come up with the equation of this line? What's the equation of this line? This straight line? You know it's going to be
Um,
y equals, and this is to
Y
scale.
equals
One-
2x plus 1.
Yeah, y equals 2x plus 1. How do you know the gradient is 2?
Because the up and down is 2 and then the cross is 1.
Yeah. So going back to our diagram, hang on. We are trying to draw a graph, a line going through 3 and 4. Okay.
Okay.
Well, the gradient, the up and down is 3, the cross is 4. So the gradient is 3 over 4. And it's going downhill, so sticking a negative in front of it. So that's our gradient. This here is our gradient. Can you see that?
Okay. Mm-hmm.
X plus C. And now you've got to work out C. What's C?
3.
Yeah, 3. So so now our equation is given by this. Okay.
Okay.
Let's just tidy this up. I'm going to put a 3 in front because it's positive and that gradient's negative. So we can write it like this. 3 over 4x. Is that okay?
Okay.
And then I can actually multiply the x to the top. So it looks like this. 3x over 4. Is that okay?
Yeah.
Okay, so now punch this into decimals and hopefully we'll draw a line going through 3 and 4. Y equals 3 minus 3x over 4. Y equals 3x. Sorry, 3
3x.
minus, no, 3 minus 3x over 4. Yeah, can you see that? It goes through 3 and it goes through 4. Okay?
Mm-hmm.
So now jump back to I drew. So now the hard part. How do we go about answering this question? We want to find the biggest area. We need to create a variable. We're just going to call A, and for any given A, it will give us the area, capital A. How do we do that?
We can replace the x with the a.
Yeah. Oh, okay. What we're going to do, Chelsea, is we're going to call this X or A. This thing here. Let's say X. For any given X, you can tell me the area, right? Because you would jump to the line, and then you can work out the area, right? So, for example, hang on. Let's say this is currently at 3, because at the moment you don't understand what's going on. So let's just put a 3 in here and then try and answer the question just so that we can understand what's going on. Suppose it's currently at 3. What's the area? You see this? We are currently at 3. So when we're at 3, so basically I'm asking you this now. If we're currently at 3, what's our area? What's capital A? What's our area?
Let me think.
What's our area?
3/4.
Yeah, you got to show you're working there. How did you get that?
I put
Show me what
3 into the x.
3 into the x, right? Like this. Put a 3 into the x, like this.
Yeah.
And then what?
And then I solved it.
Okay, so what? So that the numerator will become 9 over 4 minus 3. Is that what you did?
And
then
well, I
what?
turned 9 over 4 into a fraction, or a decimal.
Okay, you do it. Can you write it? What do you mean? Okay, and then what?
And then I subtracted.
And then that's how you got your answer, right?
Yes.
Yeah, but then that would give you the height. Because what you've done is when you put 3 into the equation, it will jump to the line. And that line there tells you, so all you've done is you found the height. I want to know the area.
Oh, then it's 2.2.
It would be what? What would you do to get the area?
I would do 3 times 0.75.
Yeah. Okay. First, Chels, let's not use decimals. It slows us down. Let's just keep it as
Fractions is
fractions.
harder. Decimals is easier for me.
No, but it's messy and you can't. Well, it's not that difficult. Let's merge these two together. You turn this into a fraction, 3/1. Take away 4/9. Sorry, 9/4. Okay, and then
Okay.
you just get the two denominators to be the same. So what do? You times top and bottom here by 4, and then what?
Then you solve.
Yeah, go and solve it. What does that become? What does this thing become?
12.
12/4, which is 3, by the way, right? 12/4, take away 9/4, and then what?
It equals 3/4.
Yeah, 3/4. It's much neater when you keep it as fractions. It's more accurate.
Yes.
Okay, so that's the height. So what's the area? What's the area?
The
Well, this
area
is
is
your
3/4.
no.
No,
That's the
no,
height.
no, no, no. The area is 9/4.
Yeah, because you would just get the height, and then you would times it by the width here, which is 3. So it gets multiplied to the top, giving you 9/4. That's the area, right?
Yes.
Okay, so now suppose you're at X. If you're at X, then what's the area? So let's say now you're currently at X. So later on we can vary X back and forth. Okay.
Okay.
Right? Okay, let's try and simulate it in decimals. So jump to decimals. Wait, what, how can you go? Yeah, next input. Draw a rectangle for given X. So instead of X, we're going to use A and then add our slider back and forth. Okay, Chelsea?
Okay.
So go to add table. So plus table, punch in the origin. So 0, 0. Okay, and then punch in, join it to our X. So it would be X across, which would, in our case, it would be A across. No, A across, because we're going to slide A back and forth.
Where?
That 4 change it to A. Yeah, A. Oh, it doesn't allow us. Oh, we need to define the slider first. So let's get rid of everything, Chelsea. Sorry, get rid of everything. New input, put in A, type A. And then it should press Y equals A. Go on. Y equals A. How come it should allow us to, is that an A? How does it know what A is? How does it know what A is? All right, put B then. Take away, instead of A, change it to a B. Small b. Hey, how does it know what B is? What's going on? Okay, get rid of that box. I'm punching 2AX. Punch next line 2AX. All right, now add our slider. I don't know how. I don't know what went wrong there. Anyway, so now that A there is our slider, we can slide A back and forth. Okay, Chelsea, get rid of the second box. So now Desmos know there's a variable called A. So now go to our input, go to the next input and then add a table. Add a table. So we need to join the origin to the point A. So the origin would be 0, 0. So 0 space 0. Yeah, and we wanted to join it up to A, 0, A across with a height of 0. Okay. So for example, if you slide A to 3, Chelsea. Slide A to 3. You should go on slide A to 3, Chelsea. Slide. No. You use a slider. Use slide it to 3. Roughly 3. Can you see that our point there? But you want to restrict it to from 0 to 4. So restrict it A from 0 to 4. We don't care about the steps. Yeah, go on. Get out of it. Okay. So now click on that circle, red circle icon for 2 seconds, and then change it to lines. Yeah, check the lines. Click on the lines at the bottom. Yeah. So now it joins it up. You see that? Now you need to jump to the diagonal line. So what's the height of the diagonal line, Chelsea?
What's the what?
What's the height of that? Oh, all right, jump back to iDrew. Jump back to iDrew. What are the coordinates at this point? Because we need to join this point up to the line. But we need to know the coordinates of this point. What's the coordinate at that point? What are the coordinates at that point? What are the? Remember, you're A across. So we are currently at A. So what are the coordinates here? It would be something, comma, something. What are the coordinates? What are the coordinates of this
I'm
point?
not sure.
Well, you moved A across, so it's going to be A across.
Oh.
Not O, A. Just told you that. Yeah, it's A across. How high up will it be? You want to jump to the line. So suppose you're at A.
3 minus 3A over 4.
Yeah. So now we need to punch this into decimals to join up the bottom point to the top point. You see that? So the coordinates there would be 3 minus 3A over 4. Can you see that?
Yes.
All right, so jump back to Desi. Now get out of there and go to your table. Go to the table. Click on a cell within that table. Any cell. So click. Yeah, cell. If you have a table, and then a table is split up into lots of different cells. Each box is called a cell. Do you get it?
No.
Well, anyway, click on the table. Click on the table anywhere on our table. You know that table 0, 0, Chelsea? No.
Yeah.
Go and click. I want you. Yeah, that's a cell there. Move to the left.
Oh, a cell.
Yeah.
I thought you were talking about like the mitochondria or like the cells in the body.
Well, we're not. We are doing maths. We're not doing biology. Yeah. So go down, or press tab or whatever. Go to the next cell, as in prison cell, not the biology cell. Okay. So now punch in. You need to join up to that point. So it'll be A. Chelsea.
Yes.
A. Basically, join up with a diagonal line. How do you do it?
Put 3.
Okay, go on then.
No.
It won't be 3, Chelsea. You need to jump to the diagonal line. And earlier you told me the diagonal line was 3 minus 3A over 4.
Oh.
Yeah, you got to jump to the diagonal line. That's like your height. 3A over 4. Yeah.
Wow.
There. Okay. Now join it to the y-axis. How do you do that? To form a rectangle, and then join it back to the origin.
Let me think.
Oh, you need to specify the across first before the height. You're specifying the height. Because when you specify the coordinates, it needs to be... No, the coordinates... the coordinates would be 0 across and then the height up.
Does it have to be straight?
Yeah, because we're drawing a rectangle. But Chelsea, no, what's the height, Chelsea, in terms of A? Because as you slide A back and forth, all right, if you do that, Chelsea, okay, leave it as it is. Slide A back and forth. You see the right-hand side.
Oh, you just need to make it straight first.
Well, I don't know. How would you go about drawing
Hold
our...
on.
Because as we slide A back and forth, you have to be able to draw our rectangle.
Give me a second.
But the thing is, the height changes as you slide A back and forth.
I don't know.
Oh, okay. Jump back to iDrew. You know, if A is right here, Chelsea, then you would jump to the line, wouldn't you? And that height there would be a lot higher than this height here. Do you agree?
Yes.
So therefore, this height would have changed. So basically, the height depends on A. So as you slide forward, the height changes, right?
Okay.
So if you're currently at A, I want to know the coordinates right here, Chelsea. What are the coordinates right here? What are the coordinates right there?
0, comma.
0, comma what? I want to know. And
think.
because you know, yeah, because you know as A changes, the height changes, you know it's got to involve A. Because you need to take into account A.
3.
3, but then 3 is fixed. That means you're always at a height. Where the height of 3 is up here. How can it be 3?
Well, if you put in 0 into the equation, it comes with 3.
Yeah, it would jump to here. But the thing is, all right, Chelsea, which height is bigger, this green height or this red height? Which one's bigger?
They're the same.
Height is... They're the same. And what earlier you said the height here was 3 minus 3x over 4. So therefore, you said that the two heights are the same. Hey, what's going on, Chelsea? No. Wait there. How come you got so many points? You're trying to draw a rectangle, and yet you've got 5 points. It's the one above that, Chelsea, isn't it? Wait, let me think. Oh no, that's right. Hang on, I'm getting confused. Whether A across. Oh, Chelsea, you're saying that the height is always at 1, but it's not.
No, I don't know what the height is. The height is
the same. Is the same as the other one. So the coordinates here would be 3 minus 3x over 4. Because it's the same height as the other point. Yeah. And then join it back to the origin.
Oh, whoa.
And as you slide it back and forth, you can see that the left height must be the same as the right height because it's a rectangle. So now you've got to find a value of A, which would give you the biggest area, and you don't know where it is, right? So you need a formula for the area, Chelsea. Do you understand?
This gives me the...
What? The biggest area? What?
3.9.
What will give you the biggest area?
No, this is the biggest area, 3.9.
No, that's the length A, Chelsea. That's just a length. You're sliding A. I want to know the area. The area is the length times the height. That's the area.
What's A?
What? You're sliding A back and forth, looking for the
Oh,
biggest.
I'm looking at the wrong one.
Yeah. So what value of A will give you the biggest area? Yeah. Slide it to 3 point something. You can see the area is small just by looking at just by using gut instinct. That seems like a small area, right?
Mm-hmm.
If A is 0. I don't know, let's say 0.3, put it on to A being 0.3. Go on, slide A to 0.3. You can see that the area is tiny. You see that? Move it to the right slightly. But somewhere in between, Chelsea, keep on moving. Somewhere in between you can see the area is getting bigger and bigger now. Remember, the area is the height times the base. It seems like it's at 2, but we don't know for sure. It could be 2.0. 2.7 could be. Go on, slide it to 2.7 or 2.2. Slide it to 2.2, Chelsea. Chelsea, you there? Yeah, it could be that one. We don't know for sure. Right?
Yes.
We'll jump back to iDream now. So for a given A, Chelsea, I want you to create a function or a machine. Jump back to iDream. I want you to come up with a formula. When I give you A, you can give me the area, capital A. How do you do that? So we are varying X. For any given X, you can tell me the area. What is it? Okay, if that's confusing, Chelsea, imagine X is 3, okay?
Okay.
Right, Chelsea? When
Okay.
X is 3, what's the area? When X is 3, what's the area? You should be able to tell me what the area is. When
I'm
X is 3, what's
thinking.
the area? Okay.
Oh, 3/4.
What?
3/4.
How do you work that out?
Because we did it before.
Yeah, I don't know what it was before, but the idea was that you jump to the height of the line and then you times the base. Do you agree?
Yes.
Okay, so suppose it's at X. Then what's the height? What's the height?
The height is 3 minus 3x over 4.
Yeah, and then so what's the area?
The area is 3 minus 3x over 4 times 3 over 4.
Well, wait, can you put it down in writing? What do you mean? So for a given value of X, you can always work out the area of the rectangle. Go on, put it down in writing. I didn't catch what you said earlier. So what's the area? It would be what? 3 minus 3x over 4, and then what?
Oh.
All right, dictate to me. What's the area?
3 times 3 minus 3x over 4.
Is that the area?
Yes.
If you write mathematics like this, people, that BODMAS thing that you do at school, they would assume that you're going to multiply that. Yeah, you've got to have brackets. But it's no longer 3, Chelsea. Earlier, I gave you an example of 3. Now I'm saying
X.
you are at a location of X.
Sorry.
Yeah. Okay, but we don't have this X here. Sorry, that's like a times. We don't use that in algebra, do we? We would write it as X bracket 3 minus 3x over 4, like this. That's just confusing. Can you see that, Chelsea?
Yeah. Oh, yeah.
Yeah. So now we've got a formula for any given value of X. Remember, X in decimals, A is our X because we're sliding A along, right?
Okay.
So for any X location, we can work out the area. Okay, Chelsea?
Okay.
So punch this into decimals, and then it will tell you the area for any given location. Do you understand? For any given A, you know the area. So jump back to Desmos. Yeah, so I want you to, so what's the area when it's when A is 0. When A is 2.2 or wherever A may be, what's the area? How do I obtain the area from Desmos?
Oh, so basically, so 2.2 would be the x right here.
Yeah.
And then you would put 2.2 into this x. And then whatever answer you get, you would times that and to get the area.
Yeah. So now what? I want to know the area. I want to know the area.
2.2?
No, well, I'm gonna
For any given, you put A into it.
Yeah. So jump to Desmos. So what's the area?
Area.
Yeah, A bracket 3 minus 3x over 4.
A over 4.
I was testing you, yeah. A over 4. Yeah. So now the area is 2.9997 or whatever it may be. Slide A back and forth, and then we're scanning to find the biggest area. Now it's getting smaller. So where do you think would give you the biggest area?
Right here at 3.
Yeah. We suspect is at 3 because it could be 3 point. Well, so the area is 3, right? But the location's at 2.
Yeah.
Yeah, we suspect that, but it could be 2.000003. We suspect it's there, but we don't know for sure. Okay, so we got to use we got to use calculus to work it out for sure. Okay, Chelsea. So jump back to iDrew.
Okay.
Jump back to iDrew. I want you to draw a graph of area for given x. Hang on. I'm gonna scroll up a bit. Bear with me. So I want you to draw this graph here, Chelsea. Area for any given value of x. So basically, draw this graph. What does this graph look like? You don't know, right?
Yeah. Yeah.
So what you do is you multiply it out, just to see what's going on. Just multiply it out. What do you get? Multiply this out. Yeah. This times this. Okay. Do you recognize this?
I recognize the 3x.
Well, 3x minus, and then this 3 over 4 is just a number, a constant, x squared. So it's like me asking you this, Chelsea. So this is back from years and years ago. We did this. I would ask you to draw this. Y equals, let's say, x squared minus 3x minus 5. How would you sketch this? This was your quadratic from years and years ago. Can you remember how to sketch this?
Yes.
And then sketch it.
Let me think.
On this graph. Yeah, intercept of -5, gradient of 3, -3, and then it wants to do a quadratic. So if I were to give you this, sketch this. Let's say x minus x squared. So it wants to do a straight line, y equals x. Remember the intercept is 0 because there's no constant. And then draw your quadratic. Why? Your quadratics should be negative because it should be an upside down quadratic. Yeah. Okay. So now going back to here, Chelsea. These are different. So what do you think this graph will look like? Sketch it. It wants to do a gradient of 3 near the origin, and then somehow create a negative.
Let me think. So.
So basically, sketch this graph. What does it look like? What's the intercept, Chelsea?
-3/4.
Is that the intercept?
Yes.
No, this Oh, well, wait there. If I were to ask you to sketch this, y equals x squared, you would draw this, right?
Yes.
If I put a 3 in front of it, it just squeezes it.
Oh.
It makes it. So that thing there just squeezes it. It doesn't change the intercept.
Yes.
What's the intercept?
Intercept 0.
Yeah. So you know it has to go through the origin. So how can you start it down here? That doesn't make
I
sense.
didn't realize.
And it has to have a gradient of 3. So have another guess. Have another sketch. How come your quadratic is positive? You can see it's a negative quadratic.
Accident.
Yeah. So what part on the graph do you think we're looking for?
What do you mean?
Or are we looking for this point, this point, this point, this point? Where on the graph? Because we're trying to find the biggest area, right? We're trying to...
We want to find the biggest point, the tallest, where the gradient is 0.
Yeah. So how do we identify where the gradient is 0? We want to find it.
You put 0 into the gradient?
So what's a gradient? What do you mean put 0 into the gradient?
I don't know.
How do we, in the past, how do we find out the highest point of a curve? Well, what's so special about the highest point on the curve? The gradient is 0, right?
You put.
So if you want to know where the gradient is 0, differentiate it, Chelsea.
Oh.
When you differentiate it, you're looking at the gradient, and you want to know where the gradient is 0. The power comes down. The x data is saying the power gets minus I1.
What I'm thinking.
Good. Okay, yeah. So now what? Oh, but by the way, Chelsea, when someone gives you a graph like this, Chelsea, it's difficult to sketch through. So what you do is you multiply it out, into this form, and then it becomes familiar. Anyway, so find the highest point, Chelsea.
The highest point is 3. You put let me think.
I want to find this highest point here. Yeah, you put 0 into the gradient, because at the highest point, the gradient would be 0. So work out a value of x that would give you a gradient of 0. Yeah, so earlier we suspect it was 2, but we didn't know for sure. Now, because we've got a graph, we can see that that is the highest point by using calculus. Okay, Chelsea? So going back to here, Chelsea, going back to Desmos, place A on 2, that will give you the biggest area. What's the biggest area?
2, the biggest area is 3.
Yeah, okay, look, when the width of the rectangle is 2, and then if you know the width is 2, then you can always work out the height by putting it into the straight line. Do you see that, Chelsea?
Yes.
You want to save it? Save that, Chelsea. Where you logged into Des. Oh, well, don't reveal any of your passwords.
Oh, it's automatic, so.
Okay. Is it saved?
Safe.
Cool.
What do I call it?
I'll call it calculus 1. Calculus 1. Okay. Save it. Okay. So next problem here, Chelsea. Can you do you know the formula for a circle? How would you draw a circle radius 10 in Desmos?
Circle
of radius 10. How would you draw a circle of radius 10?
Radius 10.
Yeah. How would you draw it? What's the formula for a circle? What?
A equals pi r squared.
Okay, so if you punch out your decimals, will it draw a circle for you?
Okay. No, I don't think so.
No, you see that's a formula for the area of the
that's what I just said. I don't think so.
Yeah, okay. Well, the formula for a circle is x squared plus y squared equals r squared. So if you want a radius of 10, put 10 into the r, so it becomes 100. So if you punch in x squared plus y squared equals 100, it will draw you a circle radius 10. So try that. Equals 100. Yeah, you can see you've got a circle radius 10. Okay, Charles?
Okay.
All right, so now jump back to iDrew. I want you to maximize the rectangle that can exist in this circle. So I want you to maximize that. Can you see that, Chelsea? Because
okay.
you could have A where A is small, so you can see that the area here is not big. Can you see that?
Yeah.
If A is so big, then you're going to get a long, thin rectangle. That's no good. But somewhere in between, there's a smooth spot somewhere where it will give you the biggest area. How do you find it the biggest?
Well, you find
Well, first, Chelsea, let's try and simulate this in decimals, because we can have A where we can slide A back and forth. Can you see that?
yes.
And then jump to the circle, and then jump over here, and then jump down here, and then jump to over here. Then you can simulate in decimals. Can you see that?
Yes.
Okay, so well, wait there. Before you go to decimals, Chelsea, before you go to decimals, jump back to iDrew. What are the coordinates for this point here? Hang on, right here, Chelsea. What are the coordinates? It would be
A comma
A comma what?
A comma
A comma what?
A comma A squared plus y squared equals 100.
No. What's the coordinates right there would be A comma 0. It has a height of 0, Chelsea.
Oh, I didn't see that. I forgot. Oops.
Okay, so now we need to jump to the line, to the circle, sorry. We need to jump to the circle. And this is the hard part. What are the coordinates here? It would be A across.
A equals, or A comma,
Yeah. It would be A comma what?
A
What's
comma.
like, Chelsea, you don't know this, Chelsea, but looking at the equation here, rearrange it to make y the subject. Go on, rearrange it to make y the subject. Because if you want to know the y value of something, then rearrange it to make y the subject. Yeah. Yeah. So when you square root something, you're supposed to have this plus minus, positive version, negative.
Yeah.
So if you jump back to decimals, Chelsea.
Oh.
Jump back to decimals. Get rid of the table. We're going to add that later on. Hide this. Yeah, get rid of the table. Discard it. Yeah. Now hide the circle. So just hide it. So click on the red circle. Yeah, you're just hiding it. Okay. Now punch in negative square root 100 minus x squared. So when you look at the minus square root.
Minus square root
100 minus x squared. Yeah, so we are looking at the negative version.
Oh.
So looking at the negative strand. Now change that minus to a plus. Yeah. So when you square root it, you get two versions: the positive version and the negative version. But we don't care about the negative version. So can we just discard the negative one? Because we're trying to create a rectangle on the positive side. So the negative one is really a bit useless, right?
Okay.
Yeah. So get rid of the negative one, Chelsea. Get rid of the negative one. Yeah. Okay. So jump back to iDrew. So Chelsea, we are trying to maximize this rectangle. Can you see that?
Yes.
But rather than dealing with the negative, let's just maximize this thing here, Chelsea. If we can maximize this green triangle, we will automatically maximize the red rectangle. Do you agree?
Okay.
Yeah. So rather than dealing with this negative side, we're just going to deal with the positive side. If we maximize the green rectangle, we will automatically maximize the red one. So let's keep it simple. Let's simplify our problem. Okay.
Okay.
All right. Now I want you to draw this rectangle in decimals. So later on we can slide A back and forth. So you need to add your slider first. Well, add a slider. I don't think Desmos likes it when you start using A without defining it first. Go on, get out of that A. Punch in A. Okay. Yeah, okay. All right. So now what's the domain for our A? From 0 to 10. Okay, cool.
10.
Well, do whatever you have to do. Draw that rectangle for me so that later on, as I slide A back and forth, it will draw us a rectangle for any given A. So join up. Yeah, you need to move A across first, don't you, Chelsea?
Oh, oops.
No, it should be A. Oh, no, you need to move across first and then the height.
Oh.
Not O, A. Just told you that.
What? What?
It's A
Cross?
across. Oh, yeah. You know, when you specify the point, you have to specify the X coordinate first and then the Y coordinate. Yeah, the X coordinate is really A. And now jump to the height. Not O, A. Just told you that. There was a height. You got to. Well, anyway, draw that. Somehow draw the rectangle for me. Looking good so far. Draw the lines in, Chelsea. Double click on that circle for 2 seconds, and then go to lines. Yeah. So far, so good.
I'm thinking.
Good. And then join it back to the origin. Okay, so now scan it back and forth and look for the biggest area, but you don't know. At the moment, you're only guessing the area from your site. You need to calculate the area for sure. So somewhere along there will give you the biggest area. Where's the biggest area, Chelsea?
5.
No, I don't think it's going to be 5. Move it slightly to the right. Move it slightly to the right of 5. I think, I don't know for sure. I think this area is bigger. I think. but we got to calculate it for sure. Okay, Chelsea.
Okay.
Save it, and then I'm going to set this for your homework because I need my
Okay.
cooking. So that's the end of our lesson. So save it, and then your homework is to find the biggest area. Okay, Chelsea.
Okay. Okay.
Yeah. So
Yeah.
come up with a formula for any given A. You're supposed to have a formula that would tell you the area for any given A. So somehow you've got to figure it out. Okay.
Okay. Okay.
All right. Yeah. So save this recording, and you don't need to send it to me. You don't need to email it to me. Because Skype will automatically